Assalamualaikum and hi everyone. Today, my group and I would like to present our road safety update project. Our team consists of 3 members, myself, Muhammad Fidul bin Azhar, Ahmad Azim and Haris Haikal. The intersection we selected is located at Fakulti Seni Bina Perancangan dan Ukur or FSPU. This location is quite active, especially during peak hour. Let me now show you the exact intersection we choose. As you can see here on the screen, we observe traffic flow from 6 directions. This direction include all the approaching and departing lanes that connect with the junction. We make sure to cover every movement, left turn, right turn and straight traffic from each side. To assess the situation comprehensively, we conducted 2 main studies, which is traffic volume study and spot speed study. Now I will show you a short video clip of the intersection that we study. This is our site location.
Although there is a speed bump and a speed limit sign indicating 30 km per hour in this area, many drivers still tend to exceed the speed limit. Most vehicles do not slow down and even continue to accelerate after passing the bump. This indicates low compliance with the speed control measures, which could be due to the straight and open road design, poorly positioned speed bump, or lack of additional enforcement elements such as rumble strips or early warning signs. In terms of alignment, the layout of this intersection is quite confusing. Some drivers are seen stopping in the middle of the intersection, unsure whether to proceed or yield. This suggests that the intersection design does not provide clear priority or direction, which increases the risk of collisions, especially when vehicles from the opposite direction do not expect sudden stops. For the cross-section, the lane width appears consistent and sufficient. However, we observe that there is no road shoulder provided. This poses a safety risk during emergencies, such as vehicle breakdowns or when motorcyclists need to swerve. Additionally, there is no physical separator between opposite traffic flows, which increases the chances of head-on or side-swipe collisions. Lastly, for roadside safety features, several important elements are missing. For instance, there are no guardrails or barriers along curve or high-risk sections. Also, open drain and green areas beside road lack proper curbs or protective features. This makes the roadside unsafe, especially if a vehicle veers off the road during an emergency or loss of control. For this study, we use a few simple tools. First, we use a hand telecounter to manually count vehicles. Every time a vehicle passes, we press the counter button according to its type. For example, motorcycle, car or lorry. Then we use a watch or a stopwatch to keep track of the time so that we know exactly when to start or stop recording. So I recorded the number of vehicles every 5 minutes and the total observation period was 2 hours. So there were 24 sets of data altogether. For each 5-minute interval, I recorded how many vehicles passed through the junction, separated by type like motorcycles, car and heavy vehicles. Actually, this kind of traffic count is more suitable to be done by at least 3 people, especially because the location we choose was a T-junction. A T-junction has 3 directions, so it's quite hard for one person to cover everything accurately. Each person usually handle 2 movements. For example, one person will observe the vehicle going straight and those turning into the junction. The second person will do the same from the opposite side. The third person will monitor the vehicles coming out from the side road. So this way we can cover all direction smoothly and make sure the data we collect is accurate and complete. Based on the data analysis, we recorded a total of 1,344 vehicles at this intersection. This gives an average hourly volume of 672 vehicles or 678 PCU per hour. The highest traffic flow came from direction 3 and direction 5, mainly involving cars and also motorcycles. According to Arahan Teknik Jalan, any intersection handling more than 500 PCU per hour is classified as high demand. Such junction should ideally be supported by proper signal facing and dedicated turning lanes. However, at this intersection, we notice that vehicle, especially those turning left, often stops in the middle of the junction, leading to potential conflicts with oncoming traffic. This situation creates delays and increases the risk of collisions.
Assalamualaikum and hi everyone. My name is Muhammad Fidor bin Azhar, and today I'm going to explain about spot speed study by using the radar gun. So, the apparatus that we're going to use is radar gun. Okay, right now I'm going to explain to you guys on how to use the radar gun. Let's go. Okay, first we need to switch on the radar gun. We're going to check it for it has battery or not. And then we're going to wait until the display screen show pass. So right now it show pass and we are ready to go. Okay, next, before we start the measurement, we need to position ourselves at a safe distance from the road, ideally facing the direction of the traffic. And then the radar gun works best when it's pointed directly at the oncoming vehicle. So we need to stay at the angle of the sideway, which is 45-degree angle to the oncoming vehicles. Okay, to start measurement, we need to hold the radar gun steady and aim it at the vehicle. When a vehicle approach, press and hold the trigger or button to start the reading. The speed will appear on the display reading and at the crosshair of the radar gun. Okay, so and then we need to record the speed of the vehicle on the data sheet along with the vehicle type and time. Repeat this for each vehicle you observe. Usually for traffic spot speed study, we need around 30 to 100 vehicles to get a good average. Thank you.
In this analysis, we will compare the radar gun data with the arahan teknik jalan ECG standard to assess traffic behavior and evaluate the accuracy of our measurement. We have calculated percentile to help us understand the speed distribution as attached in the video. By evaluating both radar gun speed and ECG guideline, we can determine if the observed speed align with the recommended traffic standard. Slower vehicle in the P15 range will typically have longer travel time, while those in the P85 range will have shorter travel time. And this comparison can help assess in traffic flow within acceptable limit as per ECG standard. For our road safety audit, we identify speeding as a major issue at the junction. According to Arahan Teknik Jalan, we propose 3 key improvements. First, relocate the speed bump closer to the junction to slow vehicle earlier. Second, install larger or clearer speed limit sign for better visibility. And lastly, add rumble strip to alert driver through vibration. This measure aims to reduce speeding and enhance safety.
For the section mitigation of road alignment, it is recommended to add warning sign, which will help alert drivers to potential hazard ahead. In addition, improving road marking will enhance visibility and better guides driver. Furthermore, installing a traffic mirror at a critical location will improve visibility at blind spot, especially for the section mitigation of road alignment. It is recommended to add warning sign, which will help alert drivers to potential hazard ahead. In addition, improving road marking will enhance visibility and better guides driver. Furthermore, installing a traffic mirror at a critical location will improve visibility at blind spot, especially for the section mitigation of road alignment. It is recommended to add warning sign, which will help alert drivers to potential hazard ahead. In addition, improving road marking will enhance visibility and better guides driver. Furthermore, installing a traffic mirror at a critical location will improve visibility at blind spot, especially for the section mitigation of road alignment. It is recommended to add warning sign, which will help alert drivers to potential hazard ahead. In addition,